Hello, online college algebra. So we're going to talk about some chapter 9 homework problems right now. So one of the things that you can look at is 4 coins are tossed and the number of heads is recorded. Shade the region on the histogram given the indicated probability. The probability that x is greater than 2. So greater than 2 is either 3 or 4. Greater than or equal to 2 would have been 2, 3, or 4. Less than or equal to would have been 0, 1, or 2. And less than would have been 0 or 1. So here my answer is C because probability that x is greater than 2 is 3 and 4. So C. So for this one, what I would do, a raffle off is the first prize of $1,000, 2 second prizes of $300, 23rd prizes of $10 each. If 20,000 tickets are sold at 50 cents each, find the expected winning for a person buying one ticket. So this is an expected value. So we needed to do one person wins $1,000, 2 people are going to win 300, 20 are going to win $10, 19,977 people are going to win nothing. But we have to take into account they actually paid 50 cents for the tickets. So the person winning $1,000 is actually winning $999.50. The person winning, the 2 people winning $300 are actually winning $299.50. The $10 winners are winning $9.50, and the people who don't win anything are actually losing 50 cents, the price of the ticket. We need to find the probability of each of them. The 1 divided by 20,000, 2 divided by 20,000, 20 divided by 20,000, and 19,977 divided by 20,000. This is going to be a sum product. We're going to multiply $999.50 times the probability that you win the $1,000 plus the $299.50 times the 2 over 20,000, which is the probability that those 2 people win in that $300. When we do that sum product, on average, the expected value is losing 41 cents. So the expected value is that the people are going to lose 41 cents, which is negative. So a survey asked respondents how many days they had eaten food prepared at a restaurant in the previous week. Probability distribution is given below. So they tell me that the probability that they didn't eat was 0. So the probability they didn't eat is 0.12, so 12%. Probability they ate once is 22%, etc. The expected value, so that's going to be a sum product. You want to go into Excel, write your 0 through 7, write your probabilities, and then use your sum product. It's basically doing what? 0 times 0.12 plus 1 times 0.22 plus 2 times 0.22 all the way down until 7 times 0.02. So 2.62 is the expected value. So this one's making sure that you know that probabilities always have to add up to 100%. The potential for your grade always has to be 100%. So think of these decimals as percentages. 0.20 is 20%. 20 plus 20 plus 20 plus 20 plus 20 is 100%. Therefore, this distribution is valid. So an example of it being invalid is what about 25% plus 10% is 35% plus another 25 plus another 25 plus another 25. That's 110%. It doesn't equal 1, therefore it's not valid. So for this one, the missing probability, remember it always has to add up to 1, so you add everyone else together. 0.01 plus 0.13 plus 0.22 plus 0.46 plus 0.09 is going to equal 0.91. Therefore, 1 minus 0.91 is 0.09. 0.09 is the missing probability. So for this one, an insurance company has written 50 policies for $100,000, 100 policies for $50,000, and 250 policies for $10,000 for people aged 20. If experience shows that the probability a person will die at age 20 is 0.0011, how much can the company expect to pay out during the year? So the first thing you have to do is find out how much the insurance policies are worth in total. 50 policies at $100,000 each is equal to my $5 million here. I should have commas in here for you so that you can see exactly what these look like. And so I also have 100 at 50,000, which is $5 million. 250 people at $10,000 is $2.5 million for a total of $12.5 million in policies that could be paid out. Multiply that by the probability of 0.0011 and you get 13,750. So when you see this exclamation point, that means factorial. So 3 factorial is going to tell me to multiply 3 times 2 times 1. Well, 3 times 2 times 1 is going to be 6. You can also use a factorial calculator. If I put the number 3 in here and say calculate, it's going to tell me that it equals 6. So the terminology we're going to have here is 7 choose 2. So that C is going to mean it's going to be a combination. That means order does not matter. There's going to be problems where we see a P and that's going to be a permutation. That's when order does matter. But for this one, order does not matter because it's combination, and we're going to say 7 choose 2. So that means we're going to have a group of 7 things, and how many ways can we choose 2 of them? And I included a calculator. So we are going to go here. So we have a combination or permutation. So a combination, 7 choose 2. So the first number goes with the N, the second number goes with the R. And we're going to say calculate, and it's going to tell me 21. So the next one here is 7 permutate 5. So my N is going to be 7, and my R is going to be 5. So I need to change my combination to a permutation. I'm going to make this 7 and this 5, and I'm going to say calculate 2,520. And that's because order matters. There's more ways that you can choose if you care who's first and who's second. The owner of Stereo Store wants to advertise, and he has many sound systems in stock. The store carries 6 different CD players, 6 different receivers, and 7 different speakers. Assume a good system consists of one of each. How many different sound systems can he advertise? So how many can he make? This goes down to how many kids' meals you can make, how many dinner combinations you can make. You're basically going to multiply 6 times 9 times 7. And if I multiply 6 times 9 times 7, I'm going to get 378. So license plate tags in a particular state are to consist of 3 letters followed by 4 digits with repeated letters and digits allowed. So your repetition is important here. How many different license plate tags can there be? Well, we have to know that there's 26 letters and there's also 10 possible digits because you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So if we jump into Excel, we know that there's 26 letters, 26 letters, 26 letters, 10 numbers, 10 numbers, 10 numbers, and 10 numbers. Where they told me about the repetition piece, repetition is allowed. That's why I have those 26 and those 10 options every time. If I multiply them all together, I get 175,760,000. 175,760,000. Okay, so this one gets a little trickier. In a certain country is rapidly running out of phone numbers. In large cities, telephone companies have introduced new area codes and are used up. Until recently, all area codes had a 0 as the middle digit, and the first digit could not be a 0 or a 1. A problem was the second digit in the area code had been used to tell phone companies long distance call was made. To avoid changing all the equipment, an alternative plan is proposed. So now we're going to have a 5-digit number, 1, 2, 3, 4, 5 digits. And they restricted the first place and the second as before. So the first one cannot be a 0 or a 1, so you're left with 8 other digits, 2, 3, 4, 5, 6, 7, 8, and 9. And then the second digit still has to be a 0, so there's only one option there. And the other 3 have any of the 10 options. So then when I do a product of those, multiply them together, I'm going to get 8,000 possible area codes. Good luck on Chapter 9. As always, reach out with questions, and I will look forward to hearing from you guys.